is today? Wednesday. So yesterday we talked about, okay, you guys kind of remember the order of stuff for acceleration, back to velocity, back to position, okay? Guys, remind me again, what are the acceleration constants due to gravity? What if it's in
9.81.
okay, so negative 9.81 if it's in what unit? Meters per second squared, yep. And then you remember the other one for acceleration?
Negative 32 feet.
Negative 32 feet per second squared, right? Okay, so those were the acceleration constants due to gravity relative to their rates there. So I'll just jot those down up there again, okay? How about example 4? Anybody want to volunteer to read that for me at all? I got it. A ball is thrown up in the air with initial velocity how fast, kids?
20 meters.
Okay, so in this part right here, if I give you an initial velocity, that's at like time 0, we assume it's already going how fast? 20 meters per second. And then we also say it's going from a height of what? 2 meters above the ground. It says find the height it gets to its highest point. I'm sorry, find the time it gets to its highest point, and then the time it hits the ground. And then the last part is how fast is the ball traveling when it hits the ground. A lot of assumptions we're going to need to make here, okay, kids? So let's first of all, let's draw a diagram of what's kind of happening here, okay? So there's this ball that's being thrown up, okay? I'm going to say that this is ground level right here. Is that okay, kids? Now we're going to assume it's thrown straight up in the air. Is that okay with you guys?
Yeah.
But it starts at a height of how much, kids?
2 meters.
2 meters above the ground, right? So then it gets thrown up, goes all the way up to a point, maybe right up here. Then when it gets to that highest point, it starts to do what then?
Fall back.
Okay, so it starts by moving upwards, gets to its highest point, and then it's going to fall all the way back down to the ground again, okay? All right, let's start working our way backwards right here. The first thing that we know right here would be the acceleration, wouldn't we? My acceleration constant at any time t is going to be that constant due to gravity. Now, granted, we're throwing this upward, but gravity is acting on it downward. So what's the acceleration constant we're going to use due to gravity here, kids? Okay, so we know A of t has to be that constant equal to negative 9.81. All right? So it says find the time it gets to its highest point. What I think you should do in all of these problems right here, guys, is find your acceleration function, find your velocity function, find your position function. Once you know all three, you can pretty much answer any of those questions after that, okay? So help me work backwards then to get to the velocity function. So I'm just going to kind of put the velocity function right over here, v of t. Okay, velocity would be the antiderivative of acceleration. Is that true? Okay, so what's the antiderivative of our acceleration? Negative 9.81 t plus some constant c out here, right, kids? Now, we got to make some assumptions about our velocity. You were told at the very beginning the initial velocity was how much? So this tells me that when t is equal to 0, velocity has to equal what value right off the bat? 20. Okay, so I'm going to plug this in to what we have already, and that's going to allow us to solve for the c value out here, isn't it? Okay, so here we go. If I plug 20 in for my velocity, set that equal to negative 9.81 times my 0 plus the c out here. Ooh, what's negative 9.81 times 0 going to get you, kiddos? 0. What's that have to make the c value? 20. So c is equal to 20. Okay, so what's that make our velocity function in the end, kids? Plus how much?
0.
Ooh, careful.
Oh, 20.
We got 20 there, right? Okay, I'm going to highlight some functions here, all right, kids? So we know we know right here, we know our acceleration function right here, right, kids? And now we know our velocity function for this. Okay. Now, kids, I could probably use the velocity function to do what? Yep, find the position function. So we're going to do that next. Right? So let me pick a different color here. All right. So let's go to our position function, which would be the antiderivative. Now again, notationally, I'm doing some things a little differently because I think it, now I could put dA dt and dv dt and all that stuff, but I think it's easier to say acceleration, velocity, and what else?
Position.
Okay, so I'm going to go ahead and go position at a certain time t. That'll be the antiderivative of this one right here, won't it? So help me out, my friends. This is going to become negative 9.81 t to what power now?
Second
Divided by, whoops, I forgot the 1. Negative 9.81 t to the second over 2 plus 20t plus some constant c, right? Let's do that in here. Okay, let's talk about our position. We know at the very beginning, what's our position, kids? 2. So at time t equal at 0, this is what we know. We know when t is equal to 0, the position is what height? Okay, so anywhere where there's a t, what am I plugging in?
0.
And anywhere where there's a p up here, what am I plugging in? Okay, now I'm going to cheat this a little bit. We're going to do 2 steps in 1. Hang in there with me. In for p, I'm going to plug in 2. Okay, that's going to equal, somebody with a calculator real quickly, go negative 9.81 divided that by 2. Let's make that one constant coefficient out in front of the t squared there.
4.9.
So negative 4.9, I'm going to call it negative 4.905. Is that okay?
Yeah, that's what it
Be a little bit more accurate. Okay, and then in for t, what am I plugging in?
is. Oh, 0.
Yep, we're looking at the initial value or the initial condition here. Okay, talk to me, friends. I've got 2 equal, what's 0 squared going to get me?
0.
Times that coefficient. 0. What's 20 times 0 going to get me? So we really have 2 is equal to 0 plus c, don't we? Okay. What's that make our position function? P of t is going to equal what in the end? I'll write it down here. You guys have a formula that says P is equal to negative 1/2 gt squared plus d sub o times t plus h sub o at all in physics?
Yeah.
Here's your negative 1/2. Here's your negative 1/2 the gravity constant times t squared plus your initial velocity. What was the initial velocity? 20 times t plus the initial height of 2. Okay.
We did this like 2 weeks too late.
Did we?
Yeah.
Does it make sense this way?
Yeah.
Okay, that's where that's all coming from. Guys, we have an acceleration function. First question.
Yes.
Do we have a velocity function for this?
Yes.
Do we have a position function to model this?
Yes.
If I have all 3 of these, we should be able to answer these questions pretty easily, right? Okay, so the first part of it is this. It says find the time it gets to its highest point and the time it hits the ground, okay? Let's do the highest point one first, all right? So I'm going to kind of divide this up like so. Do my best. Oops. Okay, so here's your highest point. Guys, let's talk about something. We'll get to the highest point. Okay, what's true? So this ball started out, or whatever was being, what was being thrown up? An object or a ball?
ball.
Okay, we throw it up the highest point. It was moving 20 meters per second. Gets to here, gets to here, gets to here. What characteristic must be true at the highest point? Relative to maybe acceleration, relative to velocity, or relative to position? What can I honestly say? Ball gets up here. Start at 20 meters per second, gets up to here.
In position.
Okay, it's its highest point, right? As I'm moving upward, what kind of velocity must you have? Positive or negative? If I'm falling down,
Negative.
you gotta have negative velocity. So at that very highest point, to transition from a positive velocity to a negative velocity, what value do you have to pass through at that highest point?
The highest point.
0. At the highest point, what should your velocity equal? 0. It's a change of direction, right? Okay? So the high point, we have to assume that that's the part where the velocity is equal to what? Right? Would you agree with that?
Yeah.
Okay. So let's go to our velocity function and set it equal to what? If I set velocity equal to 0 here, could we figure out the amount of time it takes to get to the highest point?
Yes.
Let's do that. So we're going to set 0 equal to what, my friends?
Negative 9.81 t plus 1.
Okay. Is it okay if I add 9.81 t to both sides first? Okay, let's go 2 places on this. You guys want to punch that up for me? Find the time it gets to its highest point. That's the first thing.
2.03.
2.03?
2.04.
Okay. 2.04 seconds. Okay, so that's the first part. We've done that. Then the second part, how fast is the ball traveling when it does what? Hits the ground. Well, my friends, what's the position of the ground? What value do we assume ground level? 0. So when it hits the ground, how fast is the ball going when it hits the ground? I want the velocity when it hits the ground, but we need to know the time first it hits the ground, right? So the time to hit the ground is basically saying, when is your position what value?
0.
So we got to find a position equal to what?
0.
Okay, so here's your position function. Plug in what, kids? Right? I need to refer you to something here. Guys, isn't that like an old quadratic here? So could I use quadratic formula to figure that out? But fortunately, Parson has what in his website? Okay, I'll just tell you right here, we jump in this, we know that we've got to solve a quadratic. We've got to figure out what t value works, so let's do this real quickly. If I go in here to resources and calculators again, this is a quadratic, right? So I want a quadratic formula calculator. So guys, what's our a value on this?
4.9, negative 4.905.
Okay, what's the b value on it?
20.
And what's the c value?
2.
Okay, and we'll calculate that. And guys, we get a time that's negative 0.09 seconds. Do we want our time to be negative?
No.
If time was negative, I'd look a lot better. Okay. So what time are we probably going with here?
4.
Should we call it 4.18 seconds? Is that okay? So how long is it going to take to get back to the ground here, kids, after it's been thrown up? 4.18 seconds. Okay, 4.18 seconds is what we come up with. Okay. So is it okay to say by quadratic formula calculator? What do we say here?
4.18.
Okay, so it takes 4.18 seconds, right? Now, that's the time it takes to get to the ground. So the other part of that, how fast is the ball traveling when it does hit the ground, right? When I ask you how fast something is going, is that an acceleration, velocity, or position that we're asking for? How fast is something
That'd be
going?
a velocity.
That'd be a velocity. So we really want the velocity at what time now, kids? We want the velocity at 4.18 seconds. So we jump up to here. So we need to evaluate v of what value? 4.18. Okay, so I find my velocity function. That's going to equal negative 9.81 times what value are we substituting into this velocity function right here? Okay, so this is going to be v equal negative 9.81 times 4.18 plus what value? Okay, so let me grab my calculator.
Negative 21.0058.
Negative 21.0058. 0058. So I'm just going to call it about negative 21.06. Is that all right? And that'll be in feet per what? No, meters per second, right? Meters per second. Okay. My friends, is there a lot going on that?
Yes.
Not really, not at all.
I
I think there's a lot going on here, but let me ask you this question. If you have a function for acceleration, and you have a function for velocity, and you have a function for position, does it make it easier for you to say, okay, this is what this means, so I have that function, I can solve that, okay?
That's not right.
My suggestion when you go through these types of problems, come up with all three functions first. And then once you have all three functions, go back and see what the question's really asking. Based on what the question's asking, choose your function appropriately. And then once you have the appropriate functions chosen, you're on your way to solving that stuff.
Compared to physics, I don't know, that's pretty.
What do you guys think? You okay with this right now?
think so.
Okay. Let me stop the recorder here. I do have the book page for you guys.